Hi, and welcome to the Axiom/Manhole demo screencast. I have some code up here. You should be able to find this in a GitHub gist that should be attached to this video. So let's walk through this. It starts with a bunch of imports. Skip those. First thing it does is define an Axiom item. So this is an object in an Axiom store. So we're creating a link farm. So we have a link item, and a link has a title, which is some text, so that's Unicode. Allow none is false means that you always have to supply value. We have a URL, which is a bunch of bytes, and each link has a number of votes, which is an integer that defaults to 0. Then we have a Jinja 2 template just to show some webby stuff. And a demo resource. A resource is basically just a twisted web page, essentially. So it takes a store, and what it does is it just finds all of the links currently in that store, and then it sorts them by descending number of votes, and then it renders the template that I just mentioned, and it has to encode it to UTF-8 because Jinja gives us Unicode, but render get is supposed to return this number of bytes. So if we look at that template again, you'll see that for each link in links, it just creates an anchor with the link URL and link title, and it tells you how many votes that link has. Very simple. So then we create an Axiom store, call it demo store. By passing something here, we're creating a store on disk. If you don't pass anything, then you get an in-memory store. So then we instantiate that resource that I just mentioned. And then we're going to set up Manhole. So in addition to regular globals, which you pretty much always get, we're going to give anyone who logs in access to the demo store. We're going to call that, give that the same name, and the same thing with link, which is the object that we defined earlier. Then there's a make manhole function, which basically just returns a colored manhole with those shell globals. Now, then we enter the cred parts, which is Twisted's pluggable authentication system. If you've never seen it, it kind of looks a bit funny, but there's comments in here. Essentially, what we create is a realm, which is a manhole SSH terminal realm. What that means is that when you log in, you're going to get an authenticated terminal. And then we're going to just ignore this chain protocol factory here because if you don't already know what it does, it's going to take me too long to explain. Essentially what it does is when you log in, it's going to create a protocol for you, and that's going to be a manhole, and it's the manhole function that we just defined. So I'm using colored manhole here, which is basically just almost the same thing as regular manhole, except it does some simple syntax highlighting to make it a little bit simpler, nicer even. Then we create a checker, which is basically a credentials checker. So the one we're using is called in-memory username password database don't use. You shouldn't be using this in production, but in this case we're just trying to do something simple for the demo. That same module has more interesting checkers. For example, it has a PAM checker. So if you're on a Unix box that has PAM style authentication, then you can just hook into your standard native auth. Then we create a portal. A portal is basically just a thing that hooks up, glues together a realm and any number of checkers, but in this case we only have one, so just that one checker. And then a factory, which is something that will be listening and creating new protocols when we log in. So then I start logging, and I listen on port 9080 for the website and port 9022 for SSH, and then we run the reactor. So let's see what that does. Running manhole pi, and you'll see that it started listening on port 9080, and it started listening on port 9022. So let's SSH into that, and remember that I hard-coded the username and password to be ABC and XYZ. So SSH into that, and you'll see some SSH stuff coming up. So you'll see that we're trying to do an SSH handshake, and we're providing the password XYZ, and okay, all of that worked, and we're getting an xterm. My terminal says that it's xterm color, and here's its parameters. And down here, we have a Python terminal. This is actually running in the server that you're seeing above. So this is exactly the same process, except now we have a REPL that we can actually play with. And the two objects that I was talking about earlier, so the demo store and the link class, are available to us. So let's see if close the tabs. And if we refresh that, then we'll see currently there are no links. I was playing with it earlier, so those are just a couple of links from when I was playing with this. So let's create a link instance. So we need to tell it which store to use, because otherwise it'll be in memory. And obviously, since we're querying the store every time we generate the web page, then we would never see it. And let's just try this. Well, it immediately tells you that I said that link.url should never be none, and I didn't pass one, so that doesn't work. And give it a URL. And the same thing was true for title. Notice that I have to that I'm using a Unicode string here. If I do not use a Unicode string, then we will similarly get an exception saying that link title is some text, and text has to be Unicode. You can't just make it bytes. So despite the fact that this is Python 2, Axiom is quite strict about how Unicode works. So it's a search engine, and then we should get a link object. So Google link is this. And it has 0 votes because I said that the default for that value was 0. And then when we go back to my browser and I refresh, and ta-da, we see a search engine. So, and we can do that with more links. We can create a programming language, but not APL, and make this python.org. And refresh again, and we see that those are there. And what we can do, for example, is create a Google link, and obviously Google has very high Google juice, so they're going to have lots and lots of votes. And let's give them 100 votes, and we'll see that they get 100 votes. But Python is really, really great, and even Google loves Python. So, oh yes, this is another thing. Unfortunately, on some terminals, so Command A works for jumping to the beginning of the line. Command E works for jumping to the end of the line. I have not managed to get Command K working here. So unfortunately, I don't quite know how to get that working in iTerm 2. So let's try querying for a link. Demo store query link, and this is just a query that will get all links. It's lazy by default, so if you want to get all the links, then you just turn it into a list. So it's iterable. You could add a condition here. So let's say link.title is a search engine, and we'll get the Google link. Oops. That should be double equals. And then we'll get the Google link. Notice that this is still an item query, so this thing will actually, if you list it, will have the one item inside it. For the very common pattern of give me one thing, and I know that there's exactly one thing, then you can say find unique. So find unique is pretty cool in the sense that, let's say that we do find unique with something that doesn't exist, then you'd expect to get an exception in Python, and you do get an exception in Python. And even if you do find unique with something that there are multiple of, for example, link, because there's one to Google, there's one to python.org, then you'll get duplicate unique item because you were expecting it to be unique, but it's not. Anyway, let's use the Python one. So python.org, and that's not the title, it's the URL. Link.url is that, and then we should get that link, and we can say votes is, we give Google 100 votes, so let's see what happens if we give Python 1,000 votes, and go back to the web page and refresh, then we see that, well, Python has gotten above Google. So basically, the idea is that now I've demonstrated how you can play with live objects and inspect live objects and do Axiom queries and whatever using Manhole. You don't have to use it with Axiom, but with Manhole you can get into a running server and get a REPL and all the niceties that come with that. And then another thing that I'm going to demo is upgrading. So this here on my local machine, I've called it manhole2.py, but it should be a revision in the GIS that you got. So manhole2.py, and what's different in manhole2.py, I'll just less it, is that first of all we've upgraded the schema version to 2 because I'm adding something to the schema. So that here I'm demonstrating Axiom's schema upgrade features, and we're going to give links color attribute with the default to red. And so I'm doing register attribute copying upgrader. Why? Because that's the most common kind of upgrader where you copy most of the things but you just change one or two. There's a more general API, but it's not as simple to use. Well, it's still pretty simple, but this is just a shorthand. And then I've adapted the template to include the link color. And other than that, it should be about it, except for one thing, service.iService demo start service. What does that do? Well, essentially what it does is it finds all of the magical behaviors in your store. By default, this is pretty much just a scheduler. So Axiom can run items at some point in the future, and that service has to be started, and in this case also the upgrader service. So that will basically just start finding items in your store asynchronously and find all the ones that need upgrading and upgrade them. So other than that, everything is identical. So let's just run manhole2.py. And you'll see here in the logs that it's saying beginning upgrade, and it said, I finished upgrading this dummy item. A dummy item is just an internal thing, but the important thing is dunder main link, comma 1. 1 is the version, and it's dunder main because I'm not really using a proper package. I'm just defining it in line in my script, so it's dunder main. And then it says, hey, the Axiom store that you're asking me to use is completely upgraded. So let's see if that's true. We can log in, same thing again. Again, we still have a link class. If we ask it for its schema version, then it should have the new version 2. And when we do, it just did the Control K thing again. So demo store query link. You'll see that we still have 2 links. So let's get all of them. And the first one is the Google one, and it has a color now, it's red. And the second one is the Python one, also has a color now, and it's red. It has a color because that was the default value, but you can also do whatever you want. You can, I don't know, if you wanted to use a color value based on a hash value of the URL, for example, you could do that in the upgrader. So if we refresh, then we see that suddenly the links have turned red. And of course, the same thing still applies. We can, if I grab the first one out of here, that's the Google link, then I can say Google link.color is, and make it green, and fresh. So we can still modify items as we go along. And so this was a very, very simple example of a schema upgrade because it was essentially just an append, and you didn't even need to do anything for the new value because the default is what you want it to be. But you can basically create anything you want. You can, you can delete items. For people who have seen my talk at PyConPL, you can delete items. You can add new ones. Basically anything. Like I said in the talk, I've never met a schema change so messed up that I couldn't somehow express it in Axiom. So that was everything I think I wanted to say about Axiom and Manhole, and I hope you give these tools a try. Thanks for listening.